In 2002, about 2.8 million girls competed in high school sports. The number of girls competing in high school sports has increased by an average of 0.05 million per year since 2002. We're going to do three things with this information. First, we're going to write a linear equation to find the number of girls in high school sports after 2002. Then we're going to graph the equation stating the slope and y-intercept. And then finally, we're going to estimate the number of girls competing in 2027. So in order to write a linear equation, we have to find the slope and the y-intercept. That's how we're going to write something in slope-intercept form. So the numbers that we're given are in millions, and I don't love the idea of dealing with millions. So I think what we're going to do is we're going to define our variables. Hey, buddy. I think we're going to define our variables as being in millions. So let's say G is going to be, let's make that a little thicker. G is going to be the number of girls in millions. And then for years, we could start at 2002 for years, since that's the year that we're given. But I don't love the idea of having to make a graph that goes all the way out to 2002 for the first point. So I think instead of making our x-axis be just years, let's make it years since 2002. So what this means is that 2002 will be n equals 0. And that way we don't have to make a graph that is enormous and goes all the way out into the thousands and thousands on the x-axis. And by making g, which is going to be our dependent variable on the y-axis, we don't have to make our y-axis go into the millions and millions. We can just use smaller numbers. Okay, so let's work on finding our slope and our y-intercept. And in this problem, the slope is actually a little easier to find than the y-intercept because it tells us the rate of increase. It says it has increased by an average of 0.05 million per year. So our slope is going to be 0.05. Slope is rate of increase or rate of change. It's changing by 0.05 million. So that's going to be our slope, 0.05. And then it says in 2002, there were 2.8 million competing. Since 2002 is going to be our x value, we're using n, but our x value of 0, that means 2.8 million is going to be our y-intercept. So this is going to be our b of 2.8. So our equation is going to be y equals 0.05 x plus 2.8, although since we're using g and n, we could also do it as g equals 0.05 n plus 2.8. We're not beholden to y and x. Any one of those is fine. So the next question says to graph and state the slope and y-intercept. So the slope, as we discovered, is 0.05, and the y-intercept is 2.8. And so this is going to make our graph a little difficult because we're not dealing with whole numbers. So let's go ahead and go down and do our y-intercept of 2.8, which is going to be just a tiny little bit above, or sorry, a tiny little bit below the 3. And then our slope of 0.05 is going to be a little challenging because we're going to go up 0.05 and over 1. How are we going to do up 0.05 and over 1? Well, 0.05, if we said it out loud, is 5 hundredths. And that can reduce to 1/20th. So that means we're going up 1 and over 20, which is still kind of a difficult slope for us to do, up 1 and over 20. Let's get kind of weird with this fraction here. Let's see if we can reduce it even more. Up 1 and over 20 is the same thing as if we went up 0.25 and over 5. Now, I know that's not how we normally write fractions. We don't normally have fractions that have a decimal inside of the fraction. But what I'm trying to figure out is, how much do I have to go up and over to get the slope of what this is going to be? And so I divided 1 by 4 and 20 by 4, and that's where I got 0.25 and 5. So if I go up just a tiny little bit, just about a quarter, and then over 5, that'll give me a decent estimate of what the slope looks like. So this was 2.8. I'm going to go up just about a quarter of a line, so right at 3, and then over 1, 2, 3, 4, 5. So I'm going to put my second point just right there, just a hair above the 3 on the y-axis. And let's go ahead and graph this. Starting at 2.8 and going up 0.05 million is not a fast increase, so it's not a huge slope, but that's a pretty decent estimate. Now, the reason I'm putting an arrow on one end, that is actually kind of a lousy arrow. The reason I'm putting an arrow on one end and not on the other end is because I can't have negative numbers. So I'm not going to use quadrants 2, 3, and 4. I don't want to go negative. So that's why I have a dot right here on the y-axis, but an arrow on the other end. Okay, so there's my graph. It's not the world's greatest graph. I'm not going to win any graph awards, but it's a pretty decent graph. Okay, last question. Estimate the number of girls competing in 2027. Well, the year 2027 is 5 years, oh no, sorry, 25 years after 2022. So this is going to be when n equals 25. Sorry. So we're going to take our equation, g equals 0.05 n plus 2.8, and we're going to replace the n with 25. So let's go ahead and erase this and put 25 in its place. And so that's what we're going to put into the calculator, 0.05 times 25 plus 2.8. So let's get our calculator here. We'll do 0.05 times 25 plus 2.8, and we get 4.05. So 4.05 is the number, but that doesn't really answer the question. It says estimate the number of girls competing. 4.05, remember G was in millions. So we're going to say in 2027, there will be about, because we're estimating, we don't know for sure, about 4.05 million girls competing in high school sports. I'm not going to write all that, but in high school sports, there will be about 4.05 million girls competing. Okay, so the problem gave us the slope and the y-intercept, which we used to write the equation. From the equation, we were able to sketch a graph by using the slope and the y-intercept. And then we were able to then take that equation and use it to make a prediction for what would happen in the future.